Hey everyone, Mr. Wyatt here, and we're going to take a look at numbers 9 through 15 on the Topic 8 review. Remember, the next time we have class, we will be taking the Topic 8 assessment, so I'm glad you're here to watch these videos and see how to do these problems correctly. Right now, we're looking at number 9. The probability of winning a game is 45%. How many times should you expect to win if you play 20 times? I could write it like this. The probability, I can put P for probability, of winning is 45% or equals 45%. That's how I could write it using kind of probability shorthand. Probability of winning is 45%. How many times did you expect to win if you play 20 times? All right. So in effect, what we have to figure out here is what is 45% of 20? And I could do this a couple of ways. So I'm going to call this here option 1. And then after that, I'm going to show you a second option, which actually I think might even be a little bit quicker and easier on this particular example. 45% of 20. Because we're expecting to win the game 45% of the time. We might not, or we might win more than that, but we'll see. Probably the most common way that people will do this is they'll change the percent into a decimal by moving the decimal point. I don't see the decimal point, so I know it's at the end of the number. By moving it to the left 2 spaces, 1, 2, and they get 0.45 or 45 hundredths. And then the key here is knowing that of in math means the same thing as times. It means we're multiplying by 20, in fact. Okay? When we're finding percents, sometimes people think they're supposed to divide because 45% is less than the whole thing. But no, we want to multiply. And so we have 0.45, 45 hundredths, times 20. And so if you were to go ahead and line these up, 0.45 times 20, and multiply this by hand, see we have 2-digit by 2-digit, but we do have a 0 here. 0 times 5 is 0, 0 times 4 is 0. And then we're done with the 0. We move over here to the 2 next. I need a placeholder here. 2 times 5 is 10, carry the 1. 2 times 4 is 8, plus 1 is 9. Add all these partial products together, well, you'll get 900. But then notice we do have the decimal point here. It is in 2 spaces, so we need to move our decimal point in 2 spaces in our answer, and we get 9.00 or 9 times. We could have also used a calculator to find that answer. All right, now I do want to show you another way here because 45%, the key here is to remember percent means per 100. So 45% means 45 out of 100. So what you could do is set up a proportion and say, all right, what would that equal if it were out of 20, since we're playing the game 20 times? 45 out of 100, or 45%, would be what number out of 20? I'm just going to call it N. Maybe I should have called it W for wins, but it doesn't really matter. What I do notice, though, is that 100 is compatible with 20 if I divide by 5. 100 divided by 5 is 20. Reverse that, 20 times 5 is 100. I can do that up here too, just take 45 divided by 5, and that equals 9. So just another way that you could get that same answer of 9 times. Other people, they like to do cross multiplying when they do a problem like this. And so they'll take 100, well, they'll take 20 times 45, which is 900. And then they'll divide it by the other number, which in this case is 100. And 900 divided by 100 is also 9 times. Okay, but honestly, most people would do it this way over here. Just change the percent to a decimal and multiply. All right, number 10. In a random sample of 200 customers at a restaurant, 140 customers ordered French fries. If the restaurant typically has 1,000 customers in a day, about how many will probably order French fries? Now, again, a proportion is the easy way to do this. You have your sample here. You have a survey. You have a random sample of 200 customers. 140 of them chose to order French fries. So that's 140 out of 200. Okay. You could simplify that and write 70 out of 100, since that would mean 70%, right? Since percent means per 100. But you don't have to. It's 140 out of 200 that were surveyed that chose to order French fries. So what we want to know is, what would that equal out of 1,000? Since they typically have 1,000 customers in a day, we're trying to predict how many people will order French fries so that we can make the right amount of food in the back to feed everybody. So nobody has to be told later in the afternoon, oh, I'm sorry, we're all out of French fries. You'll have angry customers if you do that. Okay, so anyway, I see 200 and 1,000 are very compatible. You can just multiply by 5. So all I have to do is multiply 140 by 5, and that should give me a good prediction of the number of people who will order fries. So I'm going to multiply 140 by 5. 5 times 0 is 0. 5 times 4 is 20. Carry the 2. 5 times 1 is 5. Add 2, that's 7. So we have 700. About how many will probably order French fries? 700 customers. So if you are operating this restaurant, you probably want to make sure you have enough frozen potatoes to make enough French fries for 700 customers per day. Maybe even a little bit more than that to make sure you don't run out. Bob's Big Boy, that used to be a popular fast food restaurant. They don't really have them. I don't know if they have them anymore or not anywhere. Number 11, 2/5 of the population have cats. That may or may not be true, but for this problem, yeah, 2/5 of the population have cats. What is the probability that the next person you ask will have a cat? Well, if you scroll down here, you're going to see all of the answer choices are decimal values. So really all we're being asked to do in this problem is figure out which of these is equivalent to 2/5. It has to be one of these 4. If you remember that fractions are all division problems, this fraction bar means divide, then you take the top number, the numerator, 2, and you divide by the bottom number, the denominator, 5. 5 won't fit into 2, so I do need a decimal point. I'll add a 0 here. I can always add more zeros as needed, bring the decimal point straight up. 5 will not go into 2, but 5 does go into 20. Exactly 4 times. 4 times 5 is 20. I get a remainder of 0. So it looks like 2/5 is the same thing as 4/10, which makes sense. If you think of this like a fraction, 4/10, 2 times 2 is 4, 5 times 2 is 10. It makes sense. But yeah, 0.4, 4/10. Number 12, an ice cream shop offers 8 different flavors of ice cream and 12 different toppings. Well, you can even try their new bacon sundae. Bacon's one of their toppings. How many choices are possible for a single serving of ice cream with one topping? All right, this is where we're using that counting principle to solve it. You have 8 different flavors of ice cream, 12 different toppings. So all you have to do is multiply those together in order to find the total number of possible outcomes. Okay, so 8 times 2 is 16, carry the 1. 8 times 1 is 8, plus 1 is 9. So how many choices are possible? 96 possible choices. That seems like a lot, doesn't it? I could actually list them all out. If I knew the different flavors and I knew the different toppings. Otherwise, I'd have to go flavor 1, topping 1, flavor 1, topping 2, flavor 1, topping 3, and so on. But there are 96 possible choices here. Number 13, now we're back to a number cube, a standard number cube with sides numbered 1 through 6. Let's say that you don't have enough time on your hands, and so you just sit and roll it 180 times. How many times would you expect to roll a 6? So first of all, we need to figure out what the probability of rolling a 6 would be. Well, there is only one face that has a 6 on it. So you have a 1 out of 6 chance of rolling and landing on a 6. So if you roll 180 times, you would expect 1/6 of those attempts, 1/6 of the 180 attempts, you would roll a 6. Okay, that's just what you're predicting. Obviously, you might roll a 6 less often than that or more often. So the easy way to do this, how do you find 1/6 of something? Divide by 6. Just like if you're finding half of something, you divide by 2, or 1/3 of something, you divide by 3, and so on. So all we have to do is divide 180 by 6. 6 times 3 is 18. I get a remainder of 0. Now, what do you do if you get a remainder of 0, but you didn't finish all your digits yet? Well, the remaining digit is a 0. You could just float it up here, and you get 30. 30 times 6 is 180. So how many times would you expect to roll a 6? 30 times. Expect to roll a 6 30 times. Okay. Now you could have also said, well, if there's a 1 in 6 chance, how many times would you roll it out of 180? Okay. I'll put a T here for times out of 180. You could write a proportion like this also, and then just take 180 times 1, which is 180, and then divide that by 6, and you still get 30 times. All right, number 14, we're almost done. Imagine you were to spin both of the attached spinners, spinner A and spinner B. How would you describe the likelihood of spinning an even number on spinner A compared to landing on the yellow space on spinner B? Now be careful, because you might be thinking, well, the yellow spaces are pretty big. I got a better chance there than I do on spinner A. But the probability of rolling an even number over here, 2, 4, and 6 are your even numbers. 1, 3, 5 are odd. So 3 out of 6, or 1/2 of these spaces, are even numbers. Over here, only 1/3 of the spaces are yellow. Okay, so how would you describe the likelihood of spinning an even number on spinner A compared to landing on the yellow space on spinner B? It's more likely that you will land on an even number on spinner A than it is that you will land on a yellow space in spinner B. And I can actually show that to you. If you look at the 2, the 4, and the 6, if you put them all together, that's half of that circle. Whereas yellow is only 1/3 of that circle, okay? So you do have a better chance. It's more likely on spinner A to land on an even number than it is to land on yellow on spinner B. Okay, number 15, and this is our last problem here. The attached chart shows the possible outcomes when you roll a standard number cube or a die 2 times. Here's your first throw right here. You can land on 1, 2, 3, 4, 5, or 6. Here's your second throw here. Again, you can land on 1, 2, 3, 4, 5, and 6. So you could land on 1 both times, or you could get 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. You could roll a 2 the first time and a 1 the second time, 2, 1, 2, 2, and so on. What is the probability of rolling the same number on both throws? If you count up all of these possible outcomes, you have 6 by 6 here, don't you? There are 36 possible outcomes. When you roll a number cube 2 times, there are 36 possible outcomes. Okay, that's the counting principle. You just take 6 times 6. 6 options here, 6 options here. 6 times 6 is 36. Now, what is the probability of rolling the same number on both throws? Well, the same number on both throws would be like a pair of 1s, a pair of 2s, a pair of 3s, a pair of 4s, a pair of 5s, a pair of 6s. So you have 6 possible outcomes where both numbers are the same out of 36 possible outcomes. Okay, now if you divide these both by 6, you find out that's a 1 in 6 chance. You actually have a 1 in 6 chance when you roll a die twice or roll a pair of dice that they'll both come up the same. Okay, so 1 out of 6 is your answer there. Good luck on the test. I'll see you later.